Welcome to Soundwaves, the podcast from Sonadine. I'm this edition's host, Michelle Barnett, Business Development Manager for Ocean Science. Today, I'm delighted to be diving into the underwater soundscape world of bearded seals with marine biology graduate student Rachel Lewis from the University of New Hampshire. Rachel, welcome. Perhaps you can start with introducing yourself and the work that you do.
Absolutely. Thank you so much for having me. I'm excited to be here. So, as you mentioned, I'm a graduate student at the University of New Hampshire in the Marine Bioacoustics and Behavioral Ecology Lab, which is a bit of a mouthful, so we call it CBABBLE for short. Our PI is Dr. Michelle Fournay, and she's been my mentor and advisor for many years. And what I focus on is listening to bearded seals in Alaska. So, underwater, they make a lot of sound, especially when they're breeding, and we can use that to track changes in their ecology over time.
Oh, that's really brilliant stuff. So I think our producer Tom has some audio he's going to feed in, so let's take a listen. I have to say that's not how I thought a seal would sound. Very unique, very unique sound. So, why bearded seal specifically?
Yeah, it's a great question. So, bearded seals are what we call ice seals, meaning that they depend on sea ice for reproduction. And they're not the only species of ice seal in Alaska, but they are the only one that does this chorusing behavior in the spring, where their vocal behavior becomes loud and constant and dominates the underwater soundscape, or basically acoustic ecosystem underwater, as it occurs. And because of that, bearded seals are a really good window into ice seal ecology and really easy to study with acoustics. And also, we work really closely with the Ice Seal Committee, which is the co management body of Alaska Native hunters that works with the US federal government to manage these populations in Alaska. And they have questions about what bearded seals are doing in response to the changes in sea ice that we're seeing.
Right. So, how did you specifically get into this field of research?
Well, I also did my undergraduate education at the University of New Hampshire, and I was an honors thesis student, and I had to figure out what I wanted to study for an honors thesis. And at the time, I had been working in a phytoplankton lab with someone I really, really enjoy, but I did not enjoy phytoplankton as much. And so I was talking with her about what maybe I wanted to do for a senior project. And Michelle had just joined the department. And after a couple unanswered emails, I knocked on her door and we got to talking. And she said, "Well, I don't have any humpback whale work for you," because that's her other thing. She does a lot of humpback whale stuff. Um, but I do have this ice seal project. Would you be interested? And I said yes. I knew nothing about ice seals. I'd never been to Alaska. I'm from New Hampshire. I've been in New Hampshire for all my education, but I was really excited to just listen to the ocean. And it just happened to be that I was listening to bearded seals in Alaska. And as you guys have heard, it's such a unique sound. I fell in love immediately.
So, tell us about the projects you're working on at the moment.
Right. So we have two study sites, one in Arctic Alaska at Ukiagvik, which is the tippy top of Alaska, as north as you can go, and one in subarctic Alaska in Bristol Bay. And in Arctic Alaska, we know that bearded seals are there because the ice is still there, and they're definitely still breeding there. So our questions when we're listening are about how is that breeding behavior changing? We know that sea ice dynamics are changing. There's longer ice-free periods in the summer, et cetera, et cetera. So the question is, are bearded seals breeding earlier in Arctic Alaska? And then going down the latitudinal gradient down to Bristol Bay, we work closely with people in a village called Todiak. And their question is, are bearded seals still breeding here at all? Can we hear any breeding chorus? Because further south in the subarctic, sea ice used to be really constant in the spring, and that's no longer the case. It's sometimes there, it's sometimes not, and they're not seeing seals like they used to see seals. So there we're listening for, are they breeding at all?
So, the two projects you've been talking about, why are they specifically important, like the locations?
Yeah, absolutely. So Up in Utqiagvik, there's this repository of acoustic data going back into the 1980s, actually. And it's not because people have been interested in bearded seals the way that I'm interested in bearded seals. It's because there's been an acoustic component to the bowhead whale census. And so there's this data that was used to count bowhead whales, essentially. But because when you're recording sound, you're recording every sound, we can opportunistically hear bearded seals in that data. So, because we're listening in Utqiagvik, we can look at decades-long changes from the 1980s up to the present day, and see how the bearded seal breeding chorus is changing, especially how when it's starting is changing. And so I've listened to 2010 and onwards. I haven't quite gotten back into the 1980s and 1990s yet, but I'm really excited to. It's one of my next steps. And then we're listening in Bristol Bay because my advisor, Dr. Michelle Fournet, was in attendance at an ice seal committee meeting one year. And one of the hunters, Mr. Sam Gussick, who's also a teacher at the Togiak School, he teaches subsistence and Yupik language classes. He was talking about hunting seals that spring, and he wasn't talking about seals at all. He was talking about moose because they weren't seeing seals. And because Michelle's expertise is in acoustics, the question came up, can we use acoustics to listen to bearded seals here? So that's why we're listening in Togiak specifically. But listening in Bristol Bay is really important right now because there's not a lot of acoustic data in the places where we are. We're doing very coastal deployments, listening for very transient marine mammal populations, and that's fairly data deficient. And so understanding what's going on in that specific subarctic region is really helpful for understanding the ecology of the species as a whole.
So this is really critical research. So, I mean, climatically, culturally, it's literally the sustenance for these communities. What are your findings so far?
So far, I'm doing preliminary work in a master's degree. Nothing's published yet. But in the Arctic, we've found this pattern where it seems like there's about 5 days between an ice breakup event, which we're kind of defining as any dip below 100% concentration, so like full ice cover. So about 5 days after an ice breakup event, the bearded seal chorus starts in spring. We don't think it's actually starting exactly 5 days after ice breakup, but what's happening is bearded seals prefer this kind of like intermediate ice concentration. So they're following ice breakup north as it occurs, and that movement takes about 5 days from an ice breakup event. And that's interesting because this pattern is something we're seeing over many years. It's something that we've modeled in data from 2010 and 2011. Then it's also something we've seen in 2024. The difference between 2010 and 2024 being that the first ice breakup event in 2010 happened in late April, and in 2024 it happened in late March, and the bearded seals chorus still started in late March. So that's a big shift in when we're hearing the chorus begin in a particular area. So we're seeing that maybe their behavior is staying consistent, they're staying in their preferred ice habitat, but that preferred ice habitat might be occurring earlier.
Oh, fascinating. So maybe you can tell us a little bit more about how you're actually collecting the data. So I appreciate it's probably quite challenging with the sea ice, and there's probably not a lot of options for you to do that. So yeah, talk us through like a typical deployment setup.
Right. So, because we're working in areas with sea ice, everything has to be below the water. If you have any kind of float with surface expression and you're leaving it out there for months on end in winter, it's going to be really easy for sea ice to snag it and move it around, and you're never going to see that instrument again. So, instead, what we do is we use an anchor and then some Sonardyne acoustic releases and rope canisters, and then we have our hydrophone attached to a line coming from that and subsurface floats. And we try to keep the whole thing like 15 to 20 feet max. So it's sitting right at the bottom of the water column. And then we leave it out there recording for months on end. I have some hydrophones out in Bristol Bay right now that have been down since September, and we're going to pick them back up in May, and they're recording almost that entire time. And then we go down and we say, okay, it's time to come back up. And we use the deck top side to set the signal, asking it to release. Watch the float come up, go over, haul it by hand in a little 20-foot skiff while you're rocking on the water, and then take the equipment back to the lab and start offloading the acoustic data.
Very nice. So it sounds like you literally wouldn't be able to do these deployments without the acoustic releases.
Exactly.
Um, so have there been any other challenges with sort of like the deployment and the recovery?
Yeah, there have been, I mean, putting any instrument into the ocean is a trial, to say the least. I rarely put something into water expecting to get it back exactly as it went in. There was the first time that I went to go retrieve instruments that we had deployed in Bristol Bay. Um, we put the nanotransponder down, pressed refresh, tried to get a signal with what we had deployed, and it said it was over 2,000 meters away from where we had left it the fall before. So that took about 5 hours of playing hide and seek, going to different spots near where we had deployed, where we thought it might have moved with currents, etc., trying to get as close as we could. And eventually we did get it back, and everything worked as it should have, which is awesome. But we think that ice had come into that study site and grabbed it and dragged it 2,000 meters. It's a really powerful force, sea ice.
I love that anecdote. So I think my penultimate question for you then, so it's all about the data, right? Um, Obviously when you get your instruments back, you want to have a sort of dig into that data, but that's a lot of audio, right, to listen to. So how do you kind of go about that? How do you process and analyze that data?
Yeah, there's a couple different ways to do it. We can look at the really big picture, which is where we create this figure called an LTSA, or long-term spectral average. And it essentially creates a heat map of sound. So the louder something is, the brighter it is on this figure. And because bearded seals are so loud, we can create these figures for an entire deployment period over many, many months and see exactly where the bearded seal breeding chorus is occurring. So that gives us a really broad overview of what's going on in the soundscape just based on how loud it is. But other than that, we have to go in and listen, actually. And I think we have some videos that we may be able to include of what it looks like in the software that we use, which is called Raven Pro. And I and my undergraduate research assistant at UNH will go through and listen for any instance of bearded seal calls. So that's actually what we're working on right now with the Bristol Bay data, is we're going through in Raven, listening to the sunrise hour every day for any instance of any seal call to figure out when seals are there. And so far, we haven't heard a single bearded seal vocalization. And when we made those long-term spectral averages, those LTSAs, we didn't see any chorusing in Bristol Bay. So that kind of gets at that second question. We think it may be starting, it being the chorus, starting earlier in the Arctic, possibly, and not happening at all in Bristol Bay. But on the other side, we have been hearing harbor seal vocalizations. So there are still seals. And I've been out with the hunters who we do field work together. They choose where the hydrophones go. I program them and put them down and listen to all the data so they don't have to. And they're still seeing ice seals, but it may be a shift in the acoustic ecology of breeding there.
Wow, fascinating, really is. Yeah, really. So I think to summarize then, what do you think your key findings, what you would say they are, and where's your research taking you? What's the next steps now?
Right. So again, key findings are a strong word. We're still working on everything. But so far, it seems like there's this strong pattern that bearded seals are not changing their preference for sea ice, which means that when sea ice is breaking up earlier, they may start breeding earlier in the Arctic. And we may be seeing a range contraction in their breeding habitat. We know they're still present in Bristol Bay. Hunters are still seeing young of year, but we're not hearing a breeding chorus. And so there may be that regime shift happening from an ice seal dominated area to a non ice seal dominated area, although harbor seals will still hang out around sea ice. So those are some of the findings we have so far. And then as far as next steps, in my near future, I'll be heading to this spring's Ice Seal Committee meeting. So I'll be presenting what I've just talked to you guys about to the hunters and federal managers who are interested in these populations. We'll talk about what it means, what they want to see next for the research, all that kind of stuff. And in the meantime, I'm working with a colleague on building an interactive website, essentially, where our hope is to take recordings of the kinds of conversations that I've been having with hunters this entire time about why bearded seals are important to them as a subsistence and cultural and nutritional resource, what kind of changes they're seeing in their seals and in their sea ice, and put that alongside what we've learned by listening to them. So, examples of the acoustic data, what those figures that I told you about look like, what the chorus sounds like, what the lack of a chorus sounds like, as a way to communicate what we're finding with the acoustics alongside why it's important. And then people from the communities that I might not have a chance to interact with because I only have 2 study sites that I can get to, or people who may not be able to come to an ISIL committee meeting can learn about what we're hearing in the seals.
Uh, That's awesome. It sounds really rewarding. That's great. That's really intriguing. And it's been really great to talk to you. We're going to wrap it up there, and I want to wish you all the best of the luck with the rest of your research. And I think we do have some more audio to end us out. So over to Tom.